Hello guys, we're back looking at the Subaru again this week. So last week we seen that adding the 3.7 volt battery made a huge difference to the model. It's really fast now, seems to have loads of power. We're even able to spin the wheels on the sandpaper, so it's pretty good now. But we still have no proportional control. So what I'm going to do today is open up the model, disconnect the old electronics and add our new electronics here. Okay, so here's the electronics we're going to put into the model today. Pretty much everything is on the little vehicle PCB here. We have our microcontroller and our motor driver. There's two motors in this, and we have a dual motor driver, so we don't need any other motor drivers for that. And we shouldn't need any servos if my plan to use the pulse width modulation to steer the wheels works. But it's possible that that won't work. I've never tried that before. We're just going to have to give it a go and see. I haven't connected the radio yet because I'm not sure whether it's going to suit best for it to be flat or standing up, because I'm not sure what the space is inside the model. So let's open it up and see what we have to work with. Here's the inside of the car. When you take off the shell, there was 5 screws holding on the shell, one in each corner and then one under the battery inside the model. So we just had to remove 5 of those. We can see our 27 megahertz antenna here. It is bent round in a loop here, but it's not really a loop antenna. This is just how they mounted the antenna. It's really just a monopole, but it's bent into this weird shape to just to confine it to the space. So you'd have limited range from this by doing that, but it doesn't really matter because you're not going to be too far away from this model. It's so small you wouldn't be able to see it to control it if you were far away from it. So under this panel here, I presume we remove these screws and we'll get access to the electronics. So I'll do that now. So here we can see our little control PCB. There's nothing complicated in there as you would expect. It's mostly through hole components and a single-sided PCB, all to keep down costs, reduce costs to the minimum. And if we can get it off, we might see if there's a chip. I suspect that that is a motor driver there, but I could be wrong. I had to desolder the pin from the battery holder there to get the PCB up. But now when we can see the bottom, it kind of looks like there's a H bridge here with these transistors for the rear motor and another H bridge here for the front motor. So I think this is probably a microcontroller that just controls the radio end of things. But that doesn't really matter. We're just going to get rid of this board because we don't want it. What we want is access to our motors, so the wires for the motors and the wires for our power switch. Hopefully we'll keep things as simple as possible. If we look at our wires here, we clearly have 2 wires for our steering, we have 2 wires for our drive motor, we have 1 wire coming from a battery terminal here going to our power switch, so that'll be the positive. And we have another battery contact here which is going to be the negative. So all we really need to do is mount our motor driver, well, our little control board in here somehow. Maybe I'll have to double back the radio on top of the main control board there so that we can put this little cover back on. But if we do that, then we'll just have to connect one motor there, the other motor just in there, and the power lines there, and that's it. There's very few connections to do. So I'll go ahead and do that, and I'll show you the result. Okay, well, here's my second attempt at this as it happens. My first attempt, as you can see here, I had this in the car, but every time I tried to drive, or at least try to drive quickly, the motor the current that the motor required was causing the voltage to drop. Now I thought this was dropping hugely, so I tried to add in capacitors. As you can see here, I actually had this capacitor and the one here on this board, and that wasn't working. So I got out the oscilloscope and had a look, and turned out the voltage was only dropping by maybe 0.3, 0.4 of a volt, and that got me thinking maybe it's the brownout. And when I looked into it a little bit, the default Arduino bootloader that I had uploaded to this board has the brownout timer set to the 2.7 volts, and that was obviously enough to cause the Arduino to reset every time we tried to drive. So what I had to do was get a new board here, because the NRF here is blocking up the pins I need to program this board with. So I did another board up here, and I changed the fuse on the in the code so that the bootloader would not, well, there would be no brownout reset when the voltage went below. Well, actually there'd be no brownout reset at all. I completely disabled it. So now I managed to get the car working. I also added the large capacitor here so that we should have enough power to take off at full speed and spin the wheels for doing donuts and trying to drift around corners, stuff like that. So other than that, it's just the normal board, same as I had in the Ford TW35. I have my drive motor hooked up here and my steering motor hooked up to the other channel of the TB6612 FNG motor driver that is there. So it's pretty straightforward. There was nothing to it really, just wired the power and wired up the two motors. And now we have perfect control, as I will now demonstrate. Okay, so off camera I have my controller here. Now remember that we just have a motor and a spring in the steering here. This is just like any normal cheap RC car. It doesn't have a servo for steering, so that means that we have no positional feedback. But by using pulse width modulation on the steering motor, we can get a little bit of control over our steering. So I'll show you now. It's obviously not as smooth as a servo, but you can see we are getting a little bit of control there. Considerably better than we had before, because previously we were just straight over and there was nothing in the middle. But now we can control it a little bit to give us a little bit of fine motor control when we're trying to steer around corners to follow the roads on a scenery or something like that. And obviously we have smooth speed control, but obviously this is much faster than a tractor, so even the slow speed is quite fast. But I'll show you here. So there you go, we have gotten steering and smooth speed control just by adding this one board. No other modifications really. Well, I did add the capacitor to hopefully prevent any brownouts or any problems with voltage dropping. But other than that, I think that was a really simple modification for one of these models, and I think it's improved it hugely. So I'll put the cover back on the model and we'll take it into the scenery, and I'll just show you how easy it is to drive this round now that we actually have some speed control. Okay, so here we have our car on the road. Let's just show you, it's a bit more controllable now. So I think we've improved that quite a bit. We still have our high speed if we wanted, but now we have a bit of fine control as well, which is a little bit more useful in this kind of application. When there's not a huge amount of space to drive around, you don't want a car that's out of control. You want to be able to easily drive it around so that you can pass the tractors and the other vehicles on the road. So I think that's a considerable improvement. The speed control especially, that makes a huge difference when you're trying to control something on one of these dioramas. Once you can get accurate speed or fine speed adjustment, it makes a huge difference. Okay, well that's the Subaru Impreza working. In future we'll have to add some LEDs for headlights and indicators and brake lights and all that sort of stuff. But for now I think it's pretty good. Hope you enjoyed that video, and if you have any comments or suggestions, let me know below the video or head on over to the forum. And don't forget to hit the like button if you liked the video, and I think that's pretty much everything, so thanks very much for watching.